Welcome. We're just so excited to have you here and to have this opportunity to share with you. My name's Esther White. We've got 2 hours together. I'm going to just introduce myself and Steph briefly, and then I'm going to talk a little bit to the piece of this CRA, but CRA with the subtleties that we know make the difference within ICRAVE methodology. And then I'm going to talk a little bit very briefly to cognitive load theory and why that's of such importance, particularly when we're working with students with complex needs. And then also to this piece of maths being a language. So that's going to be me sort of setting the frame. And then I'm going to hand over to Steph and her to be able to share what she's seen at Nepean and the transformation that they've seen because of the accurate and clear and explicit way of teaching maths as a language that they've actually implemented and seen progress for students that they never thought was possible. And really that's the message that we're here to share. It's like the way that we've taught maths to students to date, whether they're neurotypical, neurodivergent, have complex needs or don't, defies all sound judgment in terms of how we teach. And really this piece of we've taught to abstract way too quickly, or we've said let's teach abstract slower for the kids that we think need intervention, when actually we need to take a different approach that says this is a language, it needs to be started with concrete, something I can touch, feel and see, move to a representation that's proportionately accurate. I can't stress that enough. And then goes last but not least to the abstract. What are the squiggles that I'm going to use on the piece of paper to communicate this to somebody on the opposite side of the world who doesn't have the thing I can see in front of them, doesn't have a picture, but I can use these symbols to communicate something. So just wanted to welcome you all and thank you for this opportunity for us to share. And you'll see with Steph sharing her passion to make such a difference in these children's lives and the opportunity to do it with such ease and actually with grace and joy. Okay, great. And just before we start as well, I did want to mention, and I'll mention it at the end, Steph and I are actually going to be in Melbourne 20th and 21st of May doing an online, an in-person training for 2 days. And that's going to include some online self-directed training and monthly implementation sessions. But we can talk to that to the end. I just wanted to share with you Stephanie's expertise, and she'll talk to this a little bit in terms of her own experience and her heart to make a difference, and then her training and her work with Nepean Special School, and her being the lead teacher in terms of the Numeracy Intervention rollout that we did, where she undertook training with myself a couple of years ago with a small group of teachers, and then they implemented this in some part at Nepean Special School and then took it to the wider school because they were seeing these results with the students that they were working with, and then decided they'd use this approach because of the change that they were seeing and the ease that these children were learning with them making these adjustments that Steph's going to talk to. So really wanted to welcome and just honor Steph for the work. The transformation they've seen with these children has just been beautiful to experience. Just to introduce myself, so my name's Esther White. I'm the CEO of Maths Australia. I saw this way of teaching maths about 25 years ago. Australianized the program that was called Math UC that some of you might have heard about. And we promoted and made available here. And then about 10 years ago, developed a training program because we saw this need for us to, I suppose, debunk the idea that maths was difficult and really provide an opportunity for there to be a summary of how to actually teach maths, incorporating CRA, incorporating cognitive load theory, incorporating response to intervention, incorporating MTSS, incorporating UDL, all of these components. Basically, when you look at the research, we've actually been able to bring this into practice with using the explicit and clear and accurate way that we're going to present to you today. So I'm just going to be talking for a little while, and then Steph's going to take over and she's going to have the main space until about 11:30, when we have the opportunity for questions and answers. Okay, so let's just talk to cognitive load theory, because this really is a key component. And, I remember several years ago hearing a radio talk of a gentleman who started the British Association for Maths Teachers. And he was talking to this piece where he said the greatest challenge for us as teachers is going to be to see that what we think takes 12 years to teach students, we actually can teach in 4 years. And, when we look at cognitive load theory, this is really the piece of seeing when we can teach in such an accurate and clear and explicit way, when we know and understand the brain can only take in 4 to 8 pieces of new information at one time. And when you're considering students with complex needs, that's often even less. This is what, within cognitive load theory, there are several principles. We're going to look at this one of the architecture of human memory, and basically seeing when we look at this visual, and this is a visual that's available online when you look at cognitive load theory, when you see on the left-hand side, information comes in, yes? So whether it's through the senses, which we're going to talk a lot to because we have this deep understanding, our body as a human is the way that we learn, it's the way we retain information. So the more I can touch and feel and see and hear, and this congruency between each of these components, the more effective my ability is going to be able to take from my senses. And when you see with this slide, some of that is forgotten. So some of the things that happen to us, we forget, we don't retain, but then goes, as we hope, into working memory. Some of that's forgotten, and from working memory, some of it gets encoded and being able to be put into long-term memory so that we can retrieve it. Some of it's forgotten, and the rehearsal is the piece, as well as the making it multisensory, that actually supports us to put information into long-term memory. So as I said, the key piece that I just wanted to bring to your attention was this part where cognitive load theory talks to, you would have all heard of either 4 to 8 pieces of information or 3 to 7 pieces of information for a neurotypical student. But for students with complex needs, often we need to even reduce the load even further. So being aware of that piece and making sure when we teach maths, it's a language, yes? So I'm going to talk to that piece because that really informs a lot of what we're talking to now. We're going to actually be sharing with these symbols on the piece of paper don't mean anything. They never were meant to mean anything. And our proclivity where we go straight to the abstract, or we try to teach memorization, and then we sort of look at the abstract as the most important piece almost, and then we go, well, what manipulative or what plethora of manipulatives can I use to teach this student? When we use the one model and the one manipulative with color consistency, that's going to support a student so that the tool isn't the piece that takes up cognitive load. So let me just show you this piece. This part where I was saying where we're teaching a language. So really encourage you. I did a TEDx talk on this about 1.5 years ago. It's just called Why Maths is a Simple Language. For about 16 minutes, I talked to this piece. So I'm just going to talk to it briefly now, but it's a really key piece of seeing, like I said, the symbols don't mean anything. They never were meant to. And thank God, actually, that we're not using Roman numerals. Like, imagine if we had to use Roman numerals to try to teach multiplication, or Roman numerals to try to teach place value. Our beautiful positional Hindu Arabic base 10 decimal system means I can line up three numbers and another 3 numbers, and I can add my hundreds to hundreds, my tens to tens, my units to units. With Roman numerals, which we were using before Hindu Arabic, we couldn't do that at all. A C was larger than V. There wasn't any way that we could have looked at a number and immediately known that there was a number bigger than another. So what I want you to look at, because probably many of you are very experienced in terms of teaching literacy, and as a culture, we've tended to go to this structured literacy way of teaching where we know that we have to teach context and understanding and how to decode the symbols. What I want you to look at here is all of these symbols. Some of them you're familiar with. Yes, you're familiar with the C, the H, the I, E, N, but that's written in French. And unless you'd been walked through a process, you would have absolutely no idea of what C, H, I, E, N means. You could look at it and make up the sounds from English, but you still wouldn't get it because it doesn't follow the same rules. When you look at some of the other, there's Hindi, there's Yiddish, there's Chinese, there's Japanese. All of these represent this same animal, this dog, yes? But what I want you to see, if I go back to that slide, is that without the dog, the three-dimensional, and seeing pictures and somebody saying dog, 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 every time that you saw an actual dog or saw a picture of a dog, it would be similarly to me putting you in front of these symbols and teaching you a sound, but you've got nothing to attach it to. So can you just give me like a hands up or something to go, okay, I'm getting that piece a little bit, the piece that these squiggles, like when we look at maths, so coming back to first of all, to the dog, where once I see this, I've been walked through a process of I've touched, I felt, I've seen the dog, I've been shown pictures of the dog, somebody's pointed to the picture and said dog, which is abstract. If I was in France, they would have said chien. If I was in Japan, they would have said a different sound. Similarly, when I look to these symbols don't mean anything. So do you grasp that piece? The symbols, when you look at this DOG, in the language of English, we have decided DOG, when we put them together, they represent the beautiful dog that I've had a relationship with, that I've touched, felt, and seen, that now is these squiggles. I want you to see a picture of a dog. And I've actually walked you through a very explicit, clear, accurate way for touch, feel, and see the dog, draw pictures or see pictures of. Now the abstract squiggles have a picture attached to them and they're just symbols. Very key piece, because when you look at this piece, when you look at maths and think these symbols that we use for maths, the plus sign, the minus, the division, if you think about the other symbols that we use in mathematics, like the superscript, the percentage sign, think about others, sign, the square root sign, all of these symbols and the 0 to 9 are just symbols that we've decided we want these, we're going to use these in the language of maths to be able to communicate something. So have you got that piece? Yeah? Cool, because that is critical to understand. And when you see this, you go, wow, no wonder our children don't understand maths. When we go to the squiggles, I liken it to, imagine if I was to put you as an adult in front of a whole bunch of Japanese squiggles, say to you, memorize these ones go together, those ones don't go together, and, go for it. We never would do it with an adult, and yet we do it with our students. And, whether they've got complex needs or not, we do it every day of their learning lives. So that's what we're going to change, and what you're going to be part of the change with as well, to recognize the squiggles don't mean anything. I have to walk them through a process to create meaning and create understanding. And that process is very similar to the process we walk them through with teaching the language of English. The only beauty is we have a manipulative that means I've got color consistency, so the cognitive load's not needed, and this is very significant for students with complex needs. The color stays the same, And there are demarcations that mean I can teach to a unit of measure, and that student is going to be able to then apply that in all of these other areas. I don't have to teach, this is how you add kilometers, this is how you add meters, this is how you add bananas, this is how you add anything else. You've just taught 2 of something plus 3 of something is always going to equal 5 of something. And I've touched it, I've felt it, I've seen it. I've drawn pictures or had pictures presented to me or made adjustments, which Steph's going to talk to be able to see that representation piece that then means when I get to the abstract is accurate. Okay, just any questions, because I'm happy to answer questions at this stage. Any questions on that piece? No? Okay, great. Okay, so I'm going to walk through just the I-CRAVE methodology. Many of you would have heard of the CRA approach, yes? So the difference that we're going to talk to, which I talked to on the TEDx talk, is these subtleties that make every single difference and simplify the way you're going to teach. So this model here, we talk through this, it basically becomes a framework for every single lesson that you're going to teach a student. And if you've got a piece of paper, I very much encourage you to write down, even if whether you write it in a circle, or you just write it down in a sequence, I-CRAVE underneath each other. And I'm just going to talk really briefly to each of these components. So the I is identified. This is basically, we're saying we're teaching a language. Maths is a sequential language. So if I can count, now I can teach counting of units, of tens, of hundreds, and I can teach place value. Then if I can count and understand place value, now I can teach addition. And when we talk to addition, we're saying, if a student is answering 3 plus 5 as 1, 2, 3, plus 1, 2, 3, 4, 5 is 1, 2, 3, 4, 5, 6, 7, 8. They're not actually adding, they're still at counting. Addition is when I have just 2 numbers, because my plus sign is telling me I've got, a horizontal and a vertical. I've got 2 numbers, I put them together next to each other, or a 2 and a 3. The only block that's going to be the same length as that is going to be a 5 block. And I've recreated my equal symbol. So if I can count and understand place value, now I can move into addition. Then I can go to subtraction. It's the opposite of addition. Then I can go to multiplication. I'm fast adding. I'm building a rectangle now. Division is then a simple next step from there. And then once I've understood whole numbers, now I can teach fractions and decimals and percents. So that part of really important, identifying where is the student, what foundation do I currently have. The C is for the concrete, and I'm going to show you some pictures of the manipulative that we use. And Steph will talk a little bit more to this as well, and to the adjustment and what they've done at Nepean to keep this consistency for students that don't have the dexterity to be able to hold the tiny blocks that we have for general students. But this importance of concrete and the consistency of color. And I just want to say to that, the piece of, when you think about money, our physical money that, we're moving away from, but when we had money where you could look into your wallet and the color consistency meant you could see, I've got some green notes there, I've got $100 or however many hundreds of dollars, and hope that you've got more greens than purpley little $5 notes. But the color consistency was what helped a whole lot when we were working with money. And this is a really key piece to see, even when you're looking at manipulatives. If the manipulative changes every day, think of what would it feel like, even if we have no anxiety, we're totally balanced. For us, if the color of the sky changed every day, we would have to adjust. If the color of the grass changed every day, we would have to adjust. So when we look at the manipulative, staying consistent, we don't need a 3 block to be pink and yellow and blue, or one color one day, another color the next day. We just want it to be consistent so my brain can relax and I can be confident that when I look at something that's this long and it's pink, it's going to be a 3, or this long and it's yellow, it's going to be a 4. So really important that in terms of reducing cognitive load, that piece of having a consistent tool And the beauty of maths that simplifies and makes it the easiest language for us to teach a student is that we're just building rectangles. So the model's consistent, the manipulative's consistent. It means now I can actually teach the maths. I don't have to teach a tool to a student every time and take up their cognitive load that's so precious in teaching a new tool. The representational piece, I just wanted to talk to that as well more, is the key piece with this is that it's proportionally accurate. And Steph's going to talk a little bit to the adjustments that they've made for students with complex needs, but it's a step where you're wanting to take the three-dimensional concrete before you go to the abstract that's so big a jump where you've gone from something I can touch, feel, and see to now squiggles on a piece of paper. The representational piece brings the three-dimensional onto a two-dimensional piece of paper. It must be proportionately accurate. I've seen time and time and time again where the representation isn't accurate. So, seeing our base 10 model is completely dependent on 10 of this being equal to one of these, 10 units being equal to 110, 10 tens being equal to 100. That part is really critical where when we look at the concrete and the representation and the abstract, there's a congruency between every single part of that. And when you look at the verbal and the explicit, there's congruency between every single part. And you'll see this, if you're working with students with complex needs yourself at the moment, you will see if you have any inconsistencies, they will pick up on that and they will be off somewhere else while they're trying to work out the incongruency that we just taught them. So this piece that puts the onus back onto us as the teachers. I saw some paper from a PD where it had, if you imagine the number 132. So here's one red 100 block, 3 blue 10 blocks, and 2 little green unit blocks. But then when they went to the representation, then they had just a square, 2 long skinny, like no demarcations in the square, 2 long skinny rectangles that were not 1/10 of the 100, and then 2 little circles that were supposed to represent the units that the adults that were learning looked at it and went, oh, okay, that's 132, but put yourselves into your students' shoes and go, that didn't actually teach me 132 of anything because I didn't have a unit that was identified that was accurate through those pieces. Squares and rectangles and circles, they're completely different. They didn't show anything about any number. So this attention to detail that says the onus is on us and we're here to teach the way this student learns, not to try to teach them a way that we've been able to learn as a 30, 40, 50-year-old, or the adjustments we've been able to make. They're way back in the beginning of their learning journey, and we need to be so consistent and accurate with it. Make sure the concrete is accurate, the representation is accurate, the abstract then just becomes the simplest piece at the end. What squiggles do I want to use to represent this that I've understood? Okay, so really important pieces, that concrete, start with that, move to the representation, two-dimensional on a piece of paper, go to the abstract squiggles on a piece of paper. The verbal is just ensuring that you're having this communication with the student, getting that feedback all of the time. And then explicit, when we talk to explicit, we talk about accuracy of language and clear instruction. So that's the dictionary definition. So we're not specifically talking to explicit direct instruction because, as you know, particularly we're talking about students with complex needs. The teacher needs to have an understanding so they can communicate it to that student in the way that student that they know is going to understand. So it comes back to this importance of the ES or the teacher having an understanding that means they can meet the needs of that student. You can't cookie cut it. That's one thing you'll see, even what Steph's going to share with the students that she's going to talk about. There's no cookie cutting that can happen because every child is so different. But when you can use a model that's so consistent And this is what they've seen at Nepean. The model is so consistent, the representation, the way you're teaching is so consistent and so accurate. There's a way that the student can actually almost get into that stream of learning and have this confidence of, I know what the manipulatives, I can see it in my mind's eye. It's never going to change. I don't have to relearn that every single time. Okay. So I just wanted to show you this manipulative. I'm going to show you as well here. So this is, you might see on my screen, this is the little unit block, which is on the bottom left-hand side. These are like the size of 4 little Legos joined together, yeah? If you had 4 Legos in here, that would be the size of this unit block. So you can get an idea of the size there. The blocks on the right-hand side are the magnetic ones, and these are that much bigger. They're the same colors, as you can see, and at Nepean, they've actually used some of these for some of their students because, you know, they're a little bit softer on the top. Yes, they're not hollow underneath, which we use for teaching subtraction, but you can show subtraction as the difference between or the distance between anyway. So that's a little bit bigger. And then these beautiful blocks that Steph's going to show that are like humongous. That means that a student that doesn't have the dexterity to, you know, pick up this teeny weeny little block like this, they can actually pick it up and feel this is 1. You know, this is the little 2 block that was this big for the standard. This is 2. And like, you know, I can see the demarcation in it. I can hold it and feel 2 is actually as if I had 2 units. That's just this abstract sound that we use to communicate about this particular block that we're working with. There's a little bit of a distortion with the picture, but each of these are squares, which is a really critical piece. That means we can take everything we build with whole numbers, adding, subtracting, multiplying, dividing. There's a foundation to be able to do that with fractions, decimals, and percent. So nothing's going to have to be undone. Everything builds upon the next. So that's just a picture of the integer block, the magnetic ones. This is the kit we use. We take everything that they've learned for teaching fractions, decimals, and percents. And I just wanted, before I hand over to Steph, basically to show you this piece of, you know, here you can see these symbols, whether I write it vertically or horizontally, I'm teaching a way to decode. So when you think back to DOG, DOG was not the dog. 2, the symbol, plus sign 3 equals sign 5, whether I write it vertically or horizontally, is not the addition question. It's these are squiggles that I'm using. I want to be able to see, as you can see with the blocks, a 2 block, a 3 block. The only block it's going to be the same length as is going to be a 5 block. So I can recreate a picture. And, you know, we have a saying, a picture is worth 1,000 words. And yet when we're teaching maths, we go straight to the words and we basically have to teach 1,000 words where we could just show them a picture and have something I can touch, feel, and see that my mind's going to be able to create a picture of. And I really see this, you know, when you think to, you know, even as adults, nobody would give you their mobile number these days. You just won't remember it. Like nobody would expect you to. You won't be given a 6-digit of anything. If you even think about the last time you were paying a bill and you had to remember some numbers from a BSB or an account number, probably you copy and pasted it because you couldn't have confidence that you were going to remember the numbers. So this piece of saying what we know works for us as adults, we have to take a stance that says, let's put ourselves into the student shoes that we're teaching and go, what actually works for them? You know, developmentally, we know we have to have concrete before we can go to a representation or anything abstract. So I really want to just, you know, that summary of going, let's bring cognitive load theory into practice. Let's see, these symbols are just squiggles like DOG, like the Japanese, the Yiddish, the Hindi, they're just squiggles. I have to have something that's tangible and concrete for me that's accurate. And this beauty of when we're teaching maths, it's so consistent, we can just show the blocks, teach to the blocks, And you will see from what Steph's sharing, like this ease of progress that you will be so astounded to see that students, I think one of the pieces that they've seen at Nepean, these beautiful huge blocks that they printed that Steph will probably talk to, but they printed up to a 5 because they were like, probably we won't get beyond 5. And now they're like, actually, we're needing to extend because these students are extending and they're doing pieces and being able to communicate that they're understanding maths much more than anybody I think ever thought possible. And even myself, the beauty that Steph's going to share with the students that they're working with means you can take everything from something you touch, feel, and see, show the representation, draw the representation, bring it onto a two-dimensional piece of paper, and last step, go to the abstract squiggles. So yeah, just basically this reminder, the symbols, they don't mean anything. They never were meant to mean anything. And when we teach the way that we're going to share with you works, this piece of going, let's make that the last step for the students. Okay, so I'm going to hand over to Steph now. Just stop this share for a moment because I just noticed there was a question here. Jamie Lee, when we're using graph paper, should it be the same size as block units? Okay, so not necessarily, but and yes as well. So it's this piece of going, for some students, it's going to be really critical for the units to be the same size for them to put on. I do have examples of the workbooks that we've got from the Brighter Maths. And I know in some of our resources, we've got, different sizes of graph paper that you can print out for, some students as they progress. You don't want them to have to draw and build the whole big piece. You want to bring it down to a smaller part. But this, for example, when we've got really simple piece, let me see here. I think you can see that. Yeah, so when we've got this, where we're adding a 1 to another number, this is in the actual size of the blocks in the workbooks that we have. As long as you're using our CRA blocks, if you're using the MathUC, which I think about 8 years ago, we moved over to these blocks of our own that actually have the same colors, but they actually click into place, so they'll hold in place, whereas the MathUC ones didn't. And they're also a third of a size bigger. So if you're using MathUC, that may be the problem that you're seeing, is the MathUC ones are like tinier than this. So yeah, just get in touch with us. Happy to work with you on that.
Okay, so I will share my screen now. Hopefully. All right, can we all see that?
Yes.
Great. Wonderful. Okay. Thank you so much, Esther. It really is such a pleasure, and seeing how many people are here is so lovely and quite humbling, really, because I know from working with children with additional needs, it's often very difficult to find professional development experiences, webinars, et cetera, that actually relate directly to our children and can be used as is. A lot of what we do does require a lot of adjustments, as you'll see in my presentation, but it's really nice to be able to share this and know that I can give you some practical suggestions and that you could actually then go back and work with your students and use them as is, which it's very exciting. And it's lovely to see that there are so many of you out there that are wanting to make the learning experiences for your children with additional or complex needs that much richer. Okay, so a window into Nepean. So Nepean is one of only 4 schools like ours in Victoria. So our students have physical and intellectual disabilities or complex health needs. There is no IQ requirement like there is for many other schools. We have 3 full-time nurses on campus, and so we can cater for most of their medical needs throughout the day. So not only are we catering for their learning needs, but we're also catering for their health needs as well. We have a lot of students. We have about 145 students and about 110 staff. So we have teachers, principal class, admin, speech therapists, occupational therapists, physiotherapists, nurses, groundskeepers, wellbeing staff. So there is a lot of us, and the ratio of teachers or staff to students is very high. And that means that we really can offer these really individualized learning opportunities for our students. We've been around for 100 years, catering for a really wide range of students. As you can see, our cohort is broken into 3 groups, I suppose. It's our complex students, our functional students, and our independent students. So our complex students are ones that have really a lot of physical disability that needs a lot of adjustment for their learning experiences. Our functional students might have a little bit less physicality, but potentially higher intellectual needs. And then our independent learners are generally our learners that have low physical needs and low intellectual needs as well, like the students that kind of teeter on the edge of, can they go to mainstream or do they need to be in a specialised setting like ours? And then we always work in transdisciplinary teams. So we have a classroom teacher, ES as well, a speechy, a physio, an OT. Our speechies, physios, and OTs come into our classes 3 times a week, each of them. So they work with us as a full group, not taking students out and working with them individually. And we also have our wonderful music therapists who work with us 1 session a week as well. So it really is a team effort, and the work that we've been able to do at Nepean with maths is a team effort too. I may be the numeracy lead. I may be the one who began my relationship with Esther and got it running, but this information that I'm going to share with you by no means is something that I've done on my own. There are so many extremely committed, dedicated, long-standing expert teachers at Nepean that have worked with me to get it to the point that it is today. And as Esther mentioned, I do have a personal connection with Nepean as well. My younger brother attended Nepean, so I've seen it from a family point of view as well as a teacher point of view. So I've been a part of the Nepean world for a really long time, and it really is such a pleasure to be a teacher there. I wanted to add to some of our students that were our 2025 graduates were able to go on and begin university and TAFE and get part-time work, all things that have been increasing, but it's amazing to see now that we're able to support them. And it all comes down to really communication. We say at Nepean that we want our students to be able to speak to whoever they want, wherever they want, whenever they want. And maths as a language is just another element to that. We've really worked hard for them, to say what they need, when they need, how best it is for us to support them. And now we're just doing that with maths, and we're making maths another part of their language, and it's shown in the results that we've been getting from them. So as Esther said, there have been some adjustments that have been needed as with all programs. The reason that I thought that Maths Australia would be the right fit for Nepean, a few years before that, we had started a literacy program, Read, Write, Inc. and Little Learners Love Literacy and Fresh Start. I'm not sure if, I'm sure some of you are aware of those. And the things that we found that were the best for Nepean were the consistency of language, the consistency of resources, and that they could cater for all of our students, regardless of whether they were primaries, middles, or secondary. So there is a widespread of need and Victorian curriculum levels. So we're technically ungraded. Our students are ungraded, but we teach to all levels. And because of that too, it means that whatever resources we're using, whatever learning experiences we're presenting, they need to be really age respectful, because there's no point in doing a Five Little Ducks to a student who is 15, who actually really loves whatever a 15-year-old loves. So we need to bring those things into their learning experiences too. And it also means that some students are doing a lot of the same thing for a really long time. The pace of our learning is a lot slower than it is at a mainstream school. And so we need to be really respectful with giving them learning experiences that are changing too, not just the same thing all of the time. Keeping the resources consistent, but then having some variety. We say it's repetition with variety. Okay, so with that in mind, we had a literacy program that was working really well, and we found that Maths Australia was going to offer the very same sort of things. So I started with Esther, and we were all geared up to start our PD day back in 2024. And I had all of the student blocks and all of the teacher blocks, and I thought the teacher magnetic kit was perfect for our students because it was a little bit bigger. We could magnetize it to the whiteboards, individual whiteboards, which meant they'd have a little bit more resistance, and they wouldn't have to necessarily hold them. They could be stuck down. And I had one of our APs say to me, I'm not sure that all of our students are still going to be able to access these blocks. And I was like, oh man, I thought I'd covered everything. I thought we were ready to go. I was so happy that, there was things covering us already. And she said, what about the 3D printer? And I was like, what do you mean, what about the 3D printer? Sure enough, I spoke to Lewis, who is one of our groundskeepers, and he was able to offer the ability to print some blocks. So we went through the process of finding the size. We printed them solid, and then I said, no, they can't be solid. They have to be hollow at the bottom so that they can click together. We printed one and it was far too big, and then we printed one and it was too small. And so then somewhere a little bit like Goldilocks found one in the middle, and we realized that not only would we be able to do the green unit, but then we were able to make the 2 and the 3 and the 4 and the 5. And Lewis has been printing and printing and printing for about the last year and has just finished all of the filament that he purchased a year ago. And we have a whole range. They've got magnets on them. So when we started printing them, they didn't have any magnets. And then we decided to put magnets like on one side, and then we're like, no, that's not enough. So we put magnets on both sides. As they got bigger, we realized that they needed to have more magnets because they weren't necessarily sticking to the whiteboards as a teaching whiteboard on the students' trays and things like that. They could use their individual whiteboards, but yeah, we needed to keep doing different iterations, making sure the magnets were nice and stuck in there, making sure the edges were soft, all sorts of things. So it's been a real labor of love, but it's absolutely worth it. And seeing the passion that the teachers are showing to use the blocks, asking for them before they're printed, seeking us out for them, it really shows that they've been wanting something too, and now they've been able to find what they've been needing. They have, sometimes we've got Velcro on them, so they can use Velcro boards. We use Velcro boards a lot because they offer a little bit more resistance for the students. And yeah, so it's been amazing. One of the other things is voices and speaking. We have a lot of students who are nonverbal. And when we began the training, Esther highlighted how important it is for the students to talk and to hear their own voices when they're talking about the maths that they're doing and using the language. And so we really had to work with, what do our students' voices look like and how can we show their speaking? So we talk a lot about using your internal voice, which was something that we developed with the literacy program too. So, counting, we can point for them and, know that they're using their internal voice to say the numbers. A lot of our students have augmented communication. They use ALD, aided language displays. They use communication devices. So making sure that they had all of the language that they needed on those. I've also worked quite closely with some of our speechies who have really understood the importance of having this language correct for the students to make sure that the numbers are in the correct order. We used the concrete representation, the representation in their books as well, in their pod, so that they could see the green unit, then they could see the coloured of the integers, then they could also see the abstract in the numbers as well. A lot of their pods had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 0. And so we worked really hard with changing that around, making sure that it was 0 to 9 because that's your base 10. And it does take a lot of work and a lot of dedication on part of the speechies and sometimes the external therapists too, to make sure that those are correct for the students. But it just shows that it's a whole thing for the students. It's not just, in maths, this one thing. It covers a lot of different areas of their learning. Making and drawing representations, and I'll show you some pictures in the next couple of slides. But for a lot of our students who have really complex needs, they don't find it easy. I mean, they can do it with a lot of assistance, but they don't find it easy to draw or to colour. It can take a lot for our students to keep their bodies still. Sometimes they need arm gaiters, they might need their wheelchair straps on, all sorts of things to keep them in the right position for learning. And sometimes that's not something that then constitutes being able to draw and colour very easily. We also talk a lot about red light, and red light, green light. So if you've got a activity like learning 0 to 9, and drawing, and they're both red light activities, the student is going to lose, back to cognitive load, the student's going to lose the purpose of that learning experience. They're going to be concentrating so hard on keeping their body still, making sure that they're grasping the pen, that they're reaching, that they're colouring, that they've lost what it is that they're actually doing. So drawing, colouring for our students is a learning experience in itself. Counting is a learning experience in itself. So we try and take away some of that cognitive load by having Velcro. We love Velcro at Nepean, having Velcro where they can stick them on, potentially having coloured cut out blocks already. The child indicates what they want and we move it and stick it for them. So it's still their work, it's still their representation, but we're just being their arms. For other students, it might be coactive and we can do some colouring together. They just need a little bit of help to stabilise themselves. Esther was mentioning before about the colour of the blocks and how that reduces cognitive load. Not only does it reduce cognitive load for our students, but it's also a really important cue for learning. So students might sit at a particular table or in a particular position and they'll know, oh, it's time for mealtime. Oh, it's time for English. And so by having these blocks and bringing them out, they instantly go, oh, it's time for maths. And so it's not only a tool for their actual learning, but it's also a really great cue to set them up for their learning. And as I mentioned before, the pace of teaching and learning really varies. Again, it varies student to student. It's not a one size fits all. Like Esther said, there is no cookie cutter at Nepean. And so the pace of learning and teaching is very individual to the student. And it also, with Maths Australia, we are able to do that. It is so easy to be able to teach this student one thing and this student one thing because you're also using the same materials. You don't need to have a whole range of things. It just depends on what it is that they're doing, what type of square they're building with that, with those resources. So you can see here, this little person's using the teacher magnetic cube. So some of our students, our independent, highly dexterous students, use the student kit as is. Then we've got other students who benefit from using the teacher kit. And then we have other students who benefit from using our 3D printed. So we're still using all three. So you can see here that he's using a whiteboard. It's up at his level. Again, that's going to be an access thing for him, making it nice and close to him rather than bending down, using the table. And then in the middle, we've got so pictures of the 10. So that's the teacher kit, the magnetic kit. So pictures of the 10, pictures of the unit, and there's Velcro, it's laminated, the numbers are there. So the students are still making their representation, they're still counting, but there's not any drawing or colouring involved. And also, sometimes the laminating can be really helpful if we've got students who like to mouth. They will keep, that'll last a lot longer than just using paper. And then you can see an ALD there. So that has been adjusted so that it's going from 0 onwards, not from 1 and then 0 at the end. We've really worked hard on how important 0 is with the teachers and the students. And so, you know, adjusting our language in every aspect of school has really helped. And that one's high contrast for our students who have visual impairments as well.
I just want to draw your attention to see the little boy on the left-hand side. If you can see on the whiteboard, there's a 7 numeral written there. So with this piece of saying he was probably given the numeral, so the abstract, and then he had to find how many little unit blocks did he need to get. And if you look at the number of unit blocks, he's pulled out 7 little unit blocks. So that's an activity of when you think about concrete, representational, abstract, at the end stage, he'll be given the abstract, and then can he bring the concrete in? And then the next step would be, you know, what's the representation like the middle, where rather than them having to draw the representation, which is sort of the most multisensory that you can have with the student drawing themselves, but that picture that they've got of the 10 blocks and the unit blocks where if the card shuffled, they've got a blue 5 and a green 5, they have to find 5 tens and then 5 units. And you can see from the picture there that representation of something that was 3-dimensional that they've worked with. Now it's the laminated pieces of card. It's the closest piece to a representation that that particular student could work with, to then go to, now we're creating a link from when I see 55, like think back to DOG, 55 now has a picture related to it that's 5 tens and 5 units.
Thank you, Esther. One of the most important things I remember Esther saying to us when we were talking back in the beginning of the representation, how do we get our students to draw and using their own voices? It was this idea of making the representation with the student, it still is their representation. It's very different to seeing a poster on the board. They still have to make the representation together. So, you know, having the conversation in their way, making the representation in their way, it's still using that CRA and making sure that, yeah, they're hitting all of those elements in their way. I was just going to pause there for a second, just looking at my notes and making sure that I was covering everything. And I was just thinking about the pace of learning again, and particularly for our students who are functional, they who are classified as our functional learners, they really respond to repetition. So lots of the same, not only in learning experiences, but just in the way that the day is set up too. So not only did I find that it was really great to use the same, warm-up activities or whatever, it's also really good to have the same structure of the lesson. That was something that I really found, and it works and connects to what we were doing with literacy too. So I really found that, you know, we start with a song. We then have a warm-up game. We then do some one-on-one or 1-2 or 1-3, depending on the situation. Do some really focused work, something that's new, and then we have a reflection. So we're doing a review of what we've learnt before. Then we're getting to do that really targeted teaching where they need it. and then we all come back and have a reflection, and just making sure that we're doing that same cycle. And by having the same song or a couple of songs and a couple of games to choose, it really helped to tune the students in and for them to really know what it is that we're doing, that we're here for maths, and yeah, getting to use the blocks. And it really helped to reduce that cognitive load for them and make sure that they were making the gains. And I was able to see such an improvement from those students in that time. It was a long time. It was about 18 months of doing the very, similar each time. But it was absolutely well worth it. And in that 18 months, I saw a bigger jump than in the previous 18 months that I'd been working with them, doing maths in a different way. We also had some adjustments to the order of teaching as well. So usually with Maths Australia, students learn 0 to 9, and then you'll go on and do place value, and then you'll introduce the integers. For our students, particularly for my students at the time, my functional students, we focused on 0 to 5, and then we introduced the coloured integers, because I found that having that other colour actually really aided them. So we were doing 0 to 5 with the green unit blocks, and then we brought in the coloured integers, and they were able to start using the green blocks to make 2 and then find the block that's the same. And at the time I had students who had hearing impairment, so we were using lots of signing, and it was really, really, really beneficial. And so then we'd go on and we'd do 6 to 9. We'd do that with the green blocks, and then we'd do the 6 to 9 integers. And yeah, I found that it was a huge, huge thing for our kids. And we also, because we do have a lot of students that are learning pre-foundation, so A to D, we've done lots of exploration on maths through play, making sure that they're understanding that there is a reason to counting. There is a purpose behind counting, that word that I use means something to that object, to that thing. A lot of the things that you would do with students who were in kinder, or who you might have at home as your own little people, where you just count things in day to day. And so we were bringing those in and then making more formalized learning experiences for them, bringing in the unit blocks and trying just to connect it all together for them. We also had to do some adjustments with assessment as well. So we've worked really hard on how do we gather assessment that is meaningful for our students who are working at that pre-foundation level. How do we assess them in the way that they need to be assessed also, particularly for our students with access requirements. So not only are we trying to speak their language, but we're in the learning experiences, but we also really need to try and speak their language in their assessment as well. I think that's probably. So you can see here, there is a worksheet that a teacher had developed. So that was a staff member could use it, whether it's the teacher, whether it's a therapist, whether it's a ES, and they could write some feedback about what happened. So that was just another way of doing some assessment also. And then in the bottom corner, you can see a student there in her wheelchair. She's got her bus straps on, which is important for her access, but her arms are free. She's got her chest strap. She's got her belt on, so she's ready for learning physically. And she has a Velcro board there in front of her with our big 3D printed blocks with Velcro. So she's able to access them. It's nice and close to her at her level, and she can reach them and pull them off to show what she knows. And then we've also got just another nice picture of our 3D blocks, that you can see the size and the shape and the color and all those sorts of things, that they all click together, etc., etc. And as Esther showed before, That's just our set. We were able to make a full class set that Esther took over to New Zealand to show at a conference over there. And that was really exciting to know that, these things that we'd made will hopefully one day be used by lots of different students and make a real difference. So I have some videos that I wanted to show. Just making sure that I have covered everything that I want to cover. So I've got 4 videos here. 2 are with one student and 2 are with another student, so you can see the progression with them. This first video, this teacher has been working with this student for a while. I think she had him the previous year as well. And then she had done some more learning with Maths Australia, more training and her understanding of maths as a language and the importance of concrete and physicality and tactile and all of those sort of things increased. And she realized that this student really needed deep pressure when he was counting. So he doesn't have a visual impairment other than, benefits from having things bigger. He really responds to that physicality. Why? There could be a multitude of reasons. As you can see, he's quite physically disabled, but he is very intellectually able. And through these learning experiences, we've been able to see how much he really knows, which is incredible because he is at the upper end of primary. So he's been at our school for quite a while. And what this teacher was able to find out in a really short amount of time was incredible. So the adjustments he needed was the physicality. He needs one-to-one support. He's got the big blocks. He's got the numbers on Velcroed, laminated cards to show what he knows. So that's his voice to tell us. And you'll be able to see concrete working really well here. And the abstract, what could have been explored more in this video, and potentially it was outside of this little snippet, is the representation. So I'll click play and hopefully you'll be able to hear it. It's not too bad if we don't have volume. Can you hear that? No. Okay. Oh, hang on. Let's try. I can always talk for her. It's not.
Yeah, maybe if you talk, Steph, I'm not hearing it either.
So what she's done there, she had the Velcro board and she had some green blocks. I think it was 5. And she was using coactive to push his hand onto every block to help him count. She's keeping her instruction to a minimum. You can see there that he's got movement. So that's obviously something that he needs. He doesn't have his bus straps on. He's able to move. But you will see that when he answers, he really gives a movement and then he calms his body and he's able to indicate. So he's got his arms free. He can touch, and they've obviously worked that that's what he needs, that his bus straps only go on when he's going on the bus. He doesn't need those for this experience, maybe for meal times as well, but he doesn't need that for here. He needs the movement. So then she said, we're going to count. They counted. Now, how many? And she will do the coactive again, giving him the deep pressure on each number. And then she'll let go of her hand and he'll be able to indicate how many he thinks is there. Oh, it started again. There might only be 3. So looking at all of the options first. Gives him a prompt to look.
Mm.
And so he
Yeah.
was able to show that he knew how many there were straight away. He moved, he's calmed, indicated, and it was very purposeful, very intentional, pulled it off and was like, yeah, I got this. So that was at the beginning of the year. And then a little bit further in, not that much later, but a little bit further in, he'd progressed to not needing the concrete as much. He was able to count on a representation, but you'll see still, I can imagine that the pictures here are in the square because we were trying to embed maths throughout the day, and a lot of our teachers were using some sort of graphing counting experience in their morning circles. So generally it was, who is here today? And they would put pictures of the students, and then we'd put a green square over the top of them to count with the unit blocks. Another way of doing a representation on Seesaw, and just giving them those constant real life experiences too of that we're counting things. There is a reason we use these words. There is a reason that we do this. And so you can see they're still in squares. So he's got who is here today. Again, he reaches, she helps to count each person, and then he's given the abstract numbers and choosing. So he's still working on 0 to 5 at the moment, but it was not long after this that then they were able to move on to 9 because he was just kicking goals. So she's prompting him with looking, reminding him that this is where we are, we're up here. He's ready. His hand was ready. He was wanting to do it. How many? He's looking. He does that movement. His body calms.
Hmm.
A big
Yeah.
smile on his face because he knows how clever he is. So great. So then these next two videos are the complete other end. So this young man is more of a independent learner, and he's also the in this our senior school. So I think this was probably his. He's probably about 15 here, so a couple of years out from finishing. And this young man, like some of our students, was doing dual enrollment. So some of our students do attend mainstream some days, and then us other days. For various reasons, some start their schooling, like I mentioned, the young boy before. Some start their schooling with us, and then they end up moving on to mainstream. Some end their schooling with us. They might do primary in mainstream and then come to us afterwards. So we do have a wide range. So this young man, like I said, was doing dual enrollment. Here he's using the teacher kit. And I think that's probably just to build his dexterity and his his confidence when using the manipulatives. But then in the next video, he's using the student kit. And for the most part, he doesn't need a lot of adjustments. You can see a hearing aid. So his teacher would probably be potentially even the ES here, might be wearing a FM unit to help with that. But other than that, physically, he doesn't require a lot of adjustments. So he's looking at how many 5s he needs to equal 30. And then there's some other students working, and they've got their own worksheets using the blocks. They're all working at a similar level. So they're solving for the unknown, using the student kits. Students who previously had not enjoyed maths either and were very reluctant were now engaging. And then this student here is having one-to-one as she requires a little bit more assistance, but still using the student kits. And then this one here, so this is that young man again. He's using the student kits and solving for a multiplication. Again, doesn't require too many adjustments. He does have a whiteboard and he does have one-to-one, but other than that, doesn't require many things. So he is using the concrete to build this abstract here. So he's got the abstract written down, and he is now using the concrete to build. And he's been, when this video is taken, he's been doing it for a while. So I know that originally he was doing concrete, 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 and then writing. And now he's developed a some of his own, and he's going to solve using the concrete to prove it. As we always say, the blocks don't lie.
Yeah, so if I can just talk a little bit, Steph, as you watch him, the pieces to note is he's actually seeing, because this has been templated from when he did single digit multiplication, is that, you know, when you look on the abstract board, there's an across of 25 and a cross factor of 25 and an up factor of 14. So he's immediately, because of the work he's done, instead of going straight to, you know, this is one piece I look at, you know, instead of going to 5 times 4, which is the smallest part that, you know, even with our money, if you think about nowadays, we really don't care about the 5 cents times four lots of 5 cents. And yet, because we've tended to teach to abstract, we go to the smallest part. Whereas what this is teaching is he's actually gone, what's 20 times 10? Puts the 200s there, immediately has a really, you know, if you think about money, already understands if I've got buying 25 things that are $14 each, I'm going to need at least $200. Or, you know, when you think about that understanding of number, but he's actually building 25 across, 14 up. He can see it in his mind's eye. I remember seeing a video of this young man and he was talking through, you know, I've got 25 across and I've got 14 up. And then him actually, when you go to the abstract, I think in this one he might write to the smallest unit part, but that was the refinement. It's like, actually, we want to see, do you know what's the biggest piece? The 200, you know, that the ES or teacher is showing there. 200 is the most important. Then how many tens do I have? And to see that when we look in the abstract, when we teach straight to abstract, we're teaching each of these components, but it doesn't have anything visual or concrete to attach to. Whereas when you start with the concrete, the abstract is going to be so simple to do and it's done with confidence. Even with this young man, you're seeing with so much confidence, he's like, yep, this is it. I know my answer. I'm just seeing a picture in my mind's eye. Yeah, it's very cool. Yeah, and he talks through, you know, I've got this many hundreds, I've got this many tens, I've got this many units. You know, keep coming back to an image is worth 1,000 words. When you think about the last great book you read, the book enabled you to create pictures in your mind's eye, whether we're neurotypical, neurodiverse, have complex needs, have no known needs, even though we all have needs. It's like recognize that we're all going to be able to see a picture much more readily. And you can see this, the color consistency that says I'm going to have red hundreds, blue tens, green units, that basically creates a template inside the mind's eye that means that's going to be so much simpler for me to remember than symbols on a piece of paper. I'm going to have to write the piece of paper in my head, remember the numbers, regroup the numbers. There's too much cognitive load with that. Yeah. Thanks, Jeremy. Great to have you.
Wait, let me use my brain, he said while he's trying to work it out. So they're looking at which two numbers they're multiplying together next, and then finding which rectangles represent that. He needed a little bit of assistance with realizing that the green blocks were the ones that he'd just done. But this time he's like, oh, I know, I got it. So he knows that that top blue rectangle is 4 by 20.
And even when you look at the process, like how quickly he put together the blocks, 25 times 14, and how difficult or how much more time the abstract takes. Whereas
Exactly.
if he'd been able to just go, this is the blocks, I can see it, this is how many there are. But when we come to, and when I look at the abstract, even if you think about it, that 20 is that little 4 by 5 rectangle. The 80 is the 4 times 20, 4 times 20 rectangle. Then the other rectangle, then the 200, so 10 by 20 by 10 rectangle. So every part is integrated, but I can see it much more readily. I can build it much more readily. I could draw a picture or see a picture much more readily. The abstract is the most difficult if we go straight to the abstract. If you can grasp that from today, it's like the abstract is just, we don't remember numbers. I saw recently, just while you're watching that, saw recently a password manager that's just brought in, red for numerals, blue for letters, and green for special symbols. So we know that color helps us to remember, and that differentiation goes, okay, just remember this bit of information, then this, then this. But the part of us relying so much on abstract means we're actually not supporting somebody to understand with ease. Think back to Japanese symbols all in a row that you have to remember. Yeah. Steph, just wondering if you want to go to the next one. I think everyone's seen that piece.
All right. So Esther and I have been working together for the first time I worked with Esther was back in 2020. We've had our relationship at Nepean for the last 3 years, and we've learned so much. And one of the biggest things that we keep coming back to is how do we make sure that all staff have the knowledge and the language to be able to support our students. I know for us, a lot of our ES are the ones that are on the front line. They're the ones that are at the core with the students all of the time, and it is so important that they are able to have the same understanding, the same knowledge that the teachers have. So that's definitely something that Esther and I have been working on. How do we make sure that everyone has the knowledge and the understanding to be able to support our students properly? And so that kind of leads us into our professional development that's coming up in May, as Esther mentioned before. It is something that will be suitable for, principal class teachers and ES as well, making sure that everyone has all the knowledge needed. It's something that I've been able to start at Nepean, and it is so exciting and, really comforting when everyone wants that knowledge. The ES are so, craving all the understanding to be able to support the students properly. And so, yeah, that's definitely been, among many other things, that's been a really big learning and something that I'm really interested in continuing to develop for all of our staff. So thank you. That's me. I've really enjoyed this, being able to present to you all, and I hope that it's been helpful. And so, yeah, we'll have a look and see if there's question time. I'll stop sharing now, Esther.
Cool. Great. Thank you so much, Steph. I hope that's been supportive in terms of, the explanation that I went through in terms of seeing we're teaching a language, we need to look at how we can simply reduce cognitive load for students, and then even what Steph was sharing in terms of how they've actually implemented that and the change that they've seen and the ease that they've seen with their students when they've taken that understanding. It's a language, we can teach it in a very structured, very clear, very accurate, explicit way. If you think about any, even through the training, we look at this, like bring any research, when you look at response to intervention, multi-tiered systems of support, universal design for learning, Rosenshine's principles of instruction, cognitive load theory, any theory that talks to, or research that talks to, this importance of teaching in a multisensory way, and the concrete representational abstract, and particularly these subtleties that we talk to that actually make the difference. Make sure that the manipulative is going to be everything you teach here can be expanded upon and developed upon. You're not having to reteach a model. You're not having to say, we're just teaching you this for now, we're going to have to undo it later because it's not going to be transferable. If you think to cognitive load theory and that piece and what Steph was sharing about in terms of the students with their complex needs, that has to be foremount. That has to be at the forefront of how you're teaching. Has to be, how did these little ones learn? What are their ways of understanding? And we know that they have so many other components that they're grappling with for every day. So the simpler we can make maths, and I hope you can see, this piece, basically see 0 to 9, there's your alphabet, you've got a few other symbols, and with that and a model that's consistent, that's so accurate, that's got, as you saw with the, I've got some of the blocks here, but a student can actually close their eyes, same with the other blocks, and feel that's 1, that's 2, that's 3, that's 4. This is what 4 is. So when they see the symbol or the squiggle 4, we want them to see a picture of this, which will be accurate whatever my unit is. If my unit is bananas, if it's dogs, if it's fruit, if it's kilometers, but the piece of saying, when you're teaching the counting and teaching this part of maths, progressing into addition and subtraction, etc., that model being so consistent is really critical. We talked when I was at Nepean, one of the trainings, we had looking at this on one of the whiteboards. Imagine you had buttons or round circular representations. Yes, I mean, we often will use circular representations for fractions. It's like they're only useful to a certain point. Or even this, if I've got buttons out, or we might think, oh, we're just going to get buttons, and here we've got buttons that are green and pink and blue and have 2 holes or 3 holes or different shapes, and the students are going to look for all of the differences. And so this piece of going, let's reduce cognitive load and see, we just want to teach counting, we just want to teach addition, we just want to teach subtraction, and the model that says the model's consistent, the manipulative's consistent, now we can take that, go to the representation, that part that Steph talked to, saying, if they see something on a piece of paper that's out there or up on a whiteboard that's out there, it's very different to them actually working with something in front of them this way or here, but it's them doing the work to make the 3-dimensional come onto a squiggle on a piece of paper. And there has to be that gap between that's accurate. So yeah, just wanted to thank you, Steph. And I just wanted to see if there were any questions about it. And actually, before I do, Steph mentioned, and I'd mentioned at the beginning, we're both going to be at East Bentley School on the 20th and 21st of May. We are having it that the 2 days actually is the same price as what we would normally charge for one day. Basically, the first day will be me primarily going through the pedagogy, looking at response to intervention, more on the I-Crave methodology and understanding this approach that we're going to use. We usually, depending on how much work people have done with the self-directed course beforehand, we usually start working through with the blocks, because one of the key pieces is the more confident you are with the manipulative yourself, the more likely you will be to bring that in. And it's this piece that Steph mentioned, the blocks will never lie. Let's get the blocks out. They will teach us. And then this piece with the training that I'm doing with Steph, where we've got those 2 days, me on the first day walking through that. And then on the second day, Steph's going to basically take over and go, let's look at what are the adjustments that we can do with students with complex needs. What are the critical overarching pieces that you need to look at? What are the parts that have to be there that can't be adjusted? And what are the pieces that can be adjusted, and how to do that? So
I just
that's
wanted to add to Esther, although we've been able to do this as a whole school thing at Nepean, it's not necessarily that it has to be a whole school thing for you either. You might have a small group, particularly if you're from a mainstream school, you might have a small group of learners that you would really like to target their teaching, whether they're as complex as ours or not. And so, that training would be suitable for you too. I know that some of the staff from East Bentley will be there. They have quite a large cohort of people with additional needs, of students with additional needs, some as complex, some not, and they will be there too. So please don't think that just because I've got that experience in, really complex learners that it wouldn't be suitable for you. It absolutely would. I definitely want to be able to cover like as many different students and as settings as possible, because I know that so many of our PDs are often geared towards mainstream, typically developing kids. So I don't want to be, too niche in what I'm doing. I want to be able to help a wide range of teachers and students.
Oh, yeah. So I'll talk as well to dyscalculia and students with learning differences. But yeah, so that's going to be in Nepean, East Bentley, 20th and 21st of May. And the pricing for that is going to also incorporate two of the self-directed online courses. So understanding the pedagogy and the foundations of maths, what we refer to as foundations being counting, place value, addition, subtraction, telling time, and also the next level, which is the multiplication and division training. And that incorporates also monthly implementation sessions where you can come along and ask any questions in particular that you might have. So yeah, just wanted to open it up to the chat if
I can
you've got
see
any
that there's
questions.
one question there, and it said, would you please be able to go over the circular structure you use? If that's directed at me, I absolutely can do that. Or otherwise, Esther, you can step in. I did want to point on that too. The circular structure of it, I think, is really important, because one of the things that we've really been working on is that the concrete representational abstract, it doesn't always have to go that way. It can go the other way. It can go concrete, abstract, representational. Once they've got that solid understanding of the concrete, you saw, the little person on the board, he had the abstract and then he was doing the concrete, and potentially he was doing the representational after that. I think that's really important. It's not just like you've just got to do concrete, then representational, then abstract, and then you're kind of done and you move on to the next thing, or then you only work in abstract too. I think that's really important. You keep the flow, because obviously you could see with the second student how quickly he was able to make it, but then there was still understanding and knowledge that he needed to develop with knowing exactly what each of the rectangles were too. So that constant change. And for some of our students, they may never get to the point where it's just in their mind's eye and they can do abstract straight away. They might always need to have a representation or the concrete just there close by to assist them. So yeah, I just think that that's really important.
Yeah. Yeah, really key piece, just if I can say something to that, of saying when we talk to mastery, we say mastery is I can take a life situation, put it into abstract symbolic form, and I could see abstract symbolic and then relate that to an everyday life. So the situation that Steph's talking about of going, we're going to start always with the concrete, move through representational abstract, but before we progress from there, we want to check. If I give you the abstract, can you show or can you relate it to the concrete or the representation? Or if I give you the representation, can you relate it to concrete abstract? Or if I give you the concrete, can you see the representational abstract? And really, it's astounding actually when you think, oh, it's such a simple approach. Actually, once you've got that, you can mix it up in so many different ways. Use cards that show the abstract rather than them writing it or rather than you writing it, or have, like the Steph was showing, have pictures of the blocks that they can work with rather than them having to spend all this time drawing the blocks, particularly if they don't have that dexterity to be able to do it. But really simple to do it, and it basically says, okay, we've confirmed mastery. We don't need to spend extra time now on teaching all of these nuances. We actually have the understanding that means I can now build on this and introduce one other component now that I've created that schema for the students. Yeah.
I can just see that the Bridges Multisensory Learning Centre has asked, in terms of a lesson structure, what would this look like, before you chatted about reflection time as well. So for me, I would always start my lessons with my students in a circle. So we always have our students sitting either on chairs or in their wheelchair or standing frame or whatever it is that they need. So they would always be physically like that. We don't sit on the floor because it's not accessible for a lot of our kids. So they would have all of those physical requirements met first. And then we also have quite small class sizes as well, I should add. We usually don't have any more than about 8 or 9. So we'd start with a song. I forgot to add before that one of the other adjustments that we've made at Nepean is we've actually rewritten a whole heap of songs that you would find on YouTube or whatever, the 1 to 10, because that's not correct. They should be 0 to 9. So we've actually rewritten a whole heap of those, and some of our music therapists have helped with that, and we've also set them some that are suitable for primaries and some that are suitable for middle secondary. So they, are a bit more like a rap or whatever. So they can still start with a song, but they're not too kiddie. So we would start with our song, and I would usually have something in that song that we were focusing on. In our songs too, we were actually doing build, sign. So they would, build the number with the unit blocks, and they would show me the representation of the number, and then we'd sign, because, that was the voice for some of our students. So we were doing that. And then we'd do a game. Most of the time it was really, really very simple game. One of the ones that was really popular, we'd have a laminated tree, on, just an A4 tree, and we'd have a dice, and we'd roll the dice. It had the coloured integer blocks or the unit blocks on it, not the abstract. It had the representation on there. So we'd roll, the student would tell me what the number was. Everyone would make it using their green blocks, and that would be like the apples on the tree. And then when we were up to it, they were then finding the one that was the same. So they'd be finding the coloured integer block that was the same. So, we were building, showing that they were the same length, etc., etc. I did a lot of modelling. That took a long time to get to that point. But that was kind of our structure after a while. And, there was things like I would roll the dice and I would make one, and it might be 3. And then I'd make sure that they were nice and close together in a 3, because that was another really important point, knowing that 3 is not, one block over here, one block over here, and one block up here. 3 is the blocks together. So making sure that it's 0, 1, 2, 3, knowing that they're together. And then I'd find a block and I'd go, oh, is it the same length as this? And it might be a 2. No, they're different. They're not the same. And
Yeah.
then, get another one. Oh, no, that's not the same. It's too big. And then, eventually I'd find the right one. And so then they'd have a go. So we'd do that. And then, so that was practicing the skills that they'd already done. And then we'd usually break off. There'd be a group, it's usually one-on-one for one of my students. He would do, he was more focusing on 0 to 3. He also had a really severe visual impairment. So he would work one-on-one and do 0 to 3. And he was using the big blocks mainly because he was very sensory and so would put everything into his mouth. And so we found when we gave him the big block, he couldn't and he didn't like the sensation of it. And so he wouldn't mouth them. And so it then removed that need to do that. And he could actually concentrate on what it was that he wanted to do, which was incredible. I thought for ages the little ones would be good. And I was like, if he bites on it, then it's all right because they're soft. Yep, they felt really good when he bit on them. And so then he wanted to do that more. So then removing that was awesome. He loved a game that was just what's in the bag. So we'd just sing a song and he'd feel. And, the tactile was so important for him because he doesn't rely on his eyes. He relies on his touch. So he'd put his hand in, he'd feel, he'd pull the block out, would feel, and the whoever was working with him would say how many, and he'd tell us verbally how many, and he could do it. And it was just seeing the growth in that was amazing as well. And then we'd usually have maybe a student doing something, a seesaw activity that was a way for them to do a representation. So using the blocks and the colors and all of that sort of stuff as well, making them really nice and simple. But just another way of doing a representation, taking away the physicality of it. It also means that they can use those to practice things like switching and other ICT goals as well, which is great. Another way to just embed some maths in there. And then we'd have another group that was working with me and that would kind of rotate as well. And so then I'd be able to work one-on-one or one-on-two, and we'd focus on whatever the next skill was that I was working with them. We got to the point where we would using 2 coloured integers to find the same length as another coloured integer. So we were doing early addition, which was incredible. And there was quite a few students who apparently could subitize, but they could only subitize if they saw the dots in the formation of a dice. And then I'd show them another way and they wouldn't be able to do it. So a lot of it was like relearning that stuff too, making sure that they knew that 5 was 5 was 5, regardless of how you saw it as concrete or representation. So again, then we'd try and come back together and we'd either have a little song or talk about what we did or what we enjoyed or what we found difficult or, something that they wanted to do next. And like I said, that was quite a long process to get that structure. But once I developed that, I was like, oh yeah, this is where we need to be. There was lots in the beginning of just, playing with the blocks, getting used to the blocks. They'd get excited for them. But when we had that few, had the time at the beginning where they could just play, they learnt that once the blocks came out, it was time for learning. It wasn't just time for play. Sometimes we would, if some new blocks came out, then we'd have some time again just to play with them. And quite often, like they'd want to stack them. And so then I would just use that as a teaching opportunity too. Like if they put a 10 down the bottom and they put 2, oh, what did we use to make the same? Or, if they put a shorter one and then a longer one on top, does that work? Things like that. So just working with what they need to in those times. But yeah, that was kind of the structure that we were using, and it worked really well.
Awesome. Thank you, Steph. I just put into the chat the link to the Numeracy Intervention training. There's some further information on the website there about that. Yeah, if there's not any further questions, we might close out, but just wanted to thank you all for staying and giving Steph and I this opportunity to share with you what we've seen just as creating wonderful and outstanding results for students, and look forward to connecting with you more in future. Thanks so much, everybody. Bye for now.